I'm going to say log. This is an interesting thing. If you say log in VBA, it calculates natural logarithm. If you say log in the worksheet, actually, you also need to say what the base is. For natural logarithm in the worksheet, you would use ln. Okay. But here, log would be fine. Log I spot minus d mean, the whole thing divided by sigma, which is my I volley. This whole thing is d mean. Oh, actually, in this case, I'm multiplying it with t, so it's just log of I spot. Because initially t is 0, right? I'm at time 0. Now I'm going to actually dimension these trees, actual dimension. When you're letting Excel or VBA know how many numbers are going to be in there, you use the statement read them. Dim simply says there's going to be some sort of array, okay? And these things are going to be two-dimensional. So I'm going to say 0 to I step. Technically speaking, there's going to be I step number 1 entries, but I'm tagging the first one as 0. And the second dimension, we're going to say negative I step to I step. Of course, I have to tell what am I redimming. In this case, Y3. Since I'm going to do the same thing for others too, I didn't mean to indent them that much. So let's say we're doing from 100 steps. So time steps are going to be tagged from 0 to 100, and price steps are going to be from negative 100 to positive 100. So if you go back to here, come on, work with me. Say we number those steps like that. Come on. I have one more constant that I'm going to use, dim. Let's call this dy as double. As you know, dy is equal to square root of 3 times d time. Another peculiar thing, if you want to calculate square root in the worksheet, you use the function sqrt. In VBA, it's sqr. It's Microsoft for you. So this basically calculates square root of that. Then I'm going to do two. Oh, okay. Let's declare those two. Dim I row as long. Dim J row as long. Yes, yes. For I row equals 0 to I step. So for each of the time steps from 0 to 100, let's say, I'm going to actually have a second loop in here for j rho equals negative I step to I step. Remember, at the core, I have only one node. Then I'm going to have negative 1, 0, 1, negative 2, negative 1, 0, 1, 2. And y3 I rho j rho is simply equal to uh, I rho times dy. No, j rho times dy. If I'm in the second time step, the one at the very bottom is going to be negative 2 times that price step, right? So that's what my dy is. And I can immediately calculate my P3 here, x, which is e to the number. Okay, let's find that transformation. Why did I write that one? Sigma times y plus that constant times t. There should be a t in here. So I volley times y3 number, I rho j rho plus, we call that d mean times t. In this case, t is number of steps times my delta time, right? So that's I rho times I rho, that's it. Oh, times, where are you? D mean. Remember, D mean is R minus 1/2 sigma squared. In this case, I rho times D mean D time. Next J rho, next I rho. So we constructed our Y tree and the price tree. Now we're going to work on that price tree and come back. First, we're going to handle what's going to happen at the very end, okay? First, calculate the value at the very end. So let's calculate the price tree. So for J rho equals negative I step to I step. So if I step is 100, from negative 100 to 100, including 0 in there, I'm going to calculate the value of the option, okay? So if P3 I step J row is less than I strike, so price at that node is less than the strike price. What's the value of the option? Nada, right? Then O3 I step J row equals 0. Otherwise, O3 I step J row is equal to the difference between the price and the strike. So P3 that gets us done with the last step. We're done with that. Now we know what would happen when the option expires. Exactly. If you tell me the price, I'm going to tell you the value.